Question 11 asks us to sketch the graph x take 3 all squared plus y take 2 all squared is equal to 1. So by now we should recognize that this is the equation of a circle centered at 3, 2 with radius 1, right? So we go to 3, 2, radius 1, and this is going to be a bit of a mess, I'm sorry. But my circle will look something like this, where this is a circle. Hard to believe, I know, this is a circle, and this is 3, 2. Right. We then are asked to rotate this shape about the x-axis, I believe. Yes, we're asked to rotate the shape about the x-axis. So the volume of integration around the x-axis is going to be pi y squared dx. Between here, it'll be between 2 and x equals to 2 and x equals to 4. But that means we need to get this expression in terms of y. So we rearrange this. We get y take 2 squared is equal to 1 minus x take 3 all squared. So y is equal to 2 plus or minus the square root of 1 take x take 3 whole thing squared. Now if you look at this, we get two possibilities, a positive and a negative one. What does this mean? Well, actually, if I took the positive square root, the y value is 2 plus some number, then actually I get this top part of the curve, I get this top part of the curve along here. This is the part where I take y, this is where I've got y is equal to 2 plus the square root 1 take x take 3 squared. That means this bottom part, and there we go, this bottom part here, this is going to be y equals to 2 minus the square root of 1 take x take 3 squared, right? So, if I want to find the volume generated by rotating the circle about the x-axis, I'm going to have to do the top part of this, but that's going to give me the whole area. That'll give me this whole thing here. So I'm going to have to take away this bit underneath, which is where I take the negative square root. So that's how I'm going to choose my y's. So I'm going to get pi, integral between 2 and 4, of y squared, so this top one squared, so this is 2 plus the square root 1 take x take 3 squared, whole thing squared, minus this one on the bottom, this volume down here, which will be 2 minus the square root 1 take x take 3 squared, whole thing squared, dx. Now we could do this by hand if we really wanted to, but no, we do not. So we do it by calculator, and this is equal to 39.5 units cubed, right? Now, we're then asked, if we instead of rotating this, so let's just clear this up a little bit, if instead of rotating this shape about the x-axis, we'd oh god, now my circle's disappeared, hold on. If instead of rotating the shape about the x-axis, we rotated about the y-axis, would we get a bigger or a smaller volume? Well, if we compared the shapes that we would get, right, both of them would be a donut shape or a torus. But one would be this type of donut shape, right, a donut shape like this, where this distance here is 2 units because of that this distance is 2 units, right? And the other would be this type of donut shape, where this distance here was going to be 3 units, right? And these are, they have the same thickness, right? The donut is still of radius 1, but it's just how long until you get to the donut. And actually it means because I get a bigger radius, I've swept out more volume as I've rotated around. So it means that this one, V2, will actually have a bigger, larger volume, as the radius of rotation will be larger. So that is question 11.